Greetings to all, welcome to the channel Syntax05. This is the fifth video of the contact interactions in Abaqus and convergence error. In last video we discussed about the overclosure issue, and if we have overclosure problem, how we can deal with such issues. If you not gone through that video, I highly recommend to go with that video first, then only this video will be more helpful to you to remove any convergence error due to the contact. So here we can see this is my simple plate component. Basically two plates are there, they are attached with some mean of rivet. This is not a perfect rivet, but just we are assuming that is rivet. Okay. So in the first case there is no result. Software is simply representing error to us. What is that error? Let me show you. Okay, so this is the error. Just go and click on error message. Too many attempts made for this increment, and it is suggesting to see the message file, and here we have the message file. If you want to see the message file, just click on that the file, and here we have to find out the increment. Basically it starts from here, and we have to here find out the increment. If you don't want to drag too much, just you can type here and click on find. Like here I have increment, I am going to copy it, you can type also, and just click on enter. So this is the first increment keyword that found by the software. Just click on next, 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 and these are I am going to ignore actually. Okay, those are the basic setting, and this is my first increment. And for the first increment, see, this is attempt number 1, and attempt number 1 having increment size of 0.1 as we mentioned here. This is my initial attempt, initial increment that I suggested to software to converge the solution, but software cannot converge the solution due to some reasons, due to some errors. And here the warning message, numerical singularity, then this is again the warning message, displacement increment for contact is too big. So this type of problem we may face many times. Okay, this problem we may face due to number of reasons, but here I am discussing one of the most common reason. So let me minimize it, and here we are not getting any result. In the second case I gone for some modification and I am getting result, but those are not appropriate because my rivet, or you can say intermediate part, is going to move in the space. Okay, and here in the third case my results are very appropriate. This is my original model, first case, second case, and this is my third case, and here we are getting appropriate result of. Okay, this is the only agenda of this video. Right now I am starting contacts from very basic, very beginning, discussing the error which we faced most of the time. So I am just going to minimize it and exit the full screen and just go for part modeling. Let me show you the parts which I used, and again I am not going to waste time for the part modeling. Just go for isometric view. So this is my bolt component and this is my plate component. Only two component I have, and this plate component I called 2 times. Okay, then property, simple linear material I used. Just click on add it and you can see linear elastic material. Just click on OK, then go with assembly. Your assembly may look like this, then again go for the step. So in a step I used general static step with initial increment size of 0.1, total time period of 1. Here we can see initial increment size 0.1, maximum I allowed 0.1, minimum is 1 e raised to the power minus 5, and maximum number of increment hundreds. So just click on okay, till now there is no issue. Now click on interactions. In interactions, if you remember in previous video what I told you, if there is any overclosure issue and we want strain free adjustment or we want interference fit adjustment, then we have to take care of this by using some options that I discussed. So basically here we have two contacts only. One is between this plate hole and the rivet surface, and another contact between these two plates. Okay, so this is my bolt and hole contact, and you can see here. For the first case, I am not going to use any adjustment because I want to tell you those options. The default definition I am using, there is no adjustment, click on OK. And similarly for the plate to plate contact also, there is no adjustment, click on OK. Of course, you can select those surfaces very easily. And now look at the contact property, just click on edit, and here we having frictionless tangential behavior and normal behavior. By default we always choose this tangential and normal behavior. Right now just keep those options as it is, just click on OK. Then after interaction go for load, and here for the load I have one constraint at one end, and I am going to apply some displacement on another end of the plate, and this displacement is very small, 0.2 mm. Just click on OK and dismiss. Now just go for mesh. The mesh work is already done, and you can see here. Okay, so this is just a graphic error, nothing else. So after meshing you can go with the job. Before that I want to save this file in new folder, file, save as. Yeah, this is my part 5 video, and this video is on under constraint issue, actually under constraint. Okay, so save this file with existing name, click on. I am going to delete my existing results, those I created earlier. Okay, so nothing special I done. I just define the material property, assign the material property, define the general static step and interaction between this part and hole, or we can say bolt and hole, and between these two plates. Okay, that's all. So this is my job 1, and here we have basically two models. This one is with bolt and this one is without bolt. Without bolt means here we don't have bolt. Instead of bolt we have a simple rivet type of shape, or we can say simple cylinder that is going to be connect these two plates. So I am saying without bolt model, there is frictionless interaction, and there is no adjustment. So FLI, that is nothing but your frictionless interaction, and there is no adjustment. Okay, just click on continue. Define paralyzation options, number of cores I am defining 12. So again I am repeating, when I go for interaction, in interaction definition, in previous video I described those things, adjustment and no adjustment. Okay, so right now I am not going to use any adjustment, and here whatever the frictional property I have, that is actually frictionless. There is no friction. Okay, whatever the contact property I have, that is frictionless. So that's why I named the component in such way. Interaction is frictionless and there is no adjustment. And now just click on job and make sure you set the working directory also. So this is my part 5 under constraint issue, and just click on submit, and you will see the solution will not converge. It will simply show some error message to us. Let me monitor. Yeah, we can see. and simply we are getting this error message. Okay. So this error we may have due to number of reasons, but the most common reason is the under constraint problem. And what is that under constraint problem actually? See, when we model any component, we assume like here it is going to be constrained and here load is applied. We assume this assembly as in real life problem. Like if I hold two plates and fit one bolt, then what will happen to this model? Their inertia is exist, that play very important role. But in general static step, we never assume there is inertia effect in the assembly. There is no self weight, no inertia. Inertia we are simply ignoring in the general static step. If we have inertia effect, then we have to go with, of course, dynamic solution. So if there is no inertia and there is no gravity, what will happen? These components are allowed to free move in the space. If they have some restrictions, they will not move in the free space. But if there is no restrictions to those components, like this plate is fixed, okay, this plate will not move, but this bolt is not fixed with respect to these two plates. How? Because we used the frictionless contact, and once we use the frictionless contact, it can be slipped in any direction, either in the downward direction or either in the positive z direction. Similarly, once this bolt allowed to move in the free space, this plate also can move in the free space, but this is not recommended by the software. If such condition is happening, this is called under constraint problem. Means your components are not properly constrained, or your assembly components not properly constrained with respect to each other, and they allow to float in the free space. Of course, in the dynamic analysis, those are allowed. Like if we solve this problem with explicit or implicit dynamic, then we have inertia effect, and due to that inertia effect, they will allow to move. But here in general static step, they don't have inertia, so nothing is going to be restrict those motions. In dynamic analysis, their inertia going to be restrict their motion, okay, and equilibrium will be achieved for the component, like dynamic equilibrium, not equilibrium. But in the general static step, there is nothing like dynamic equilibrium, and that's why software unable to converge the solution, and that is called under constraint issue. So this is the simplest example to show you, but many times what happen, we have complex assembly and we not define contact and interactions properly for few components or maybe even one component, then software unable to converge the solution, especially for the large assemblies where we have number of components. Okay, in previous video I also talked about the initial adjustment options. Let me show you. Like you may think in previous video we used the adjustment options and our problem got solved, but let me show you. Just click on here, adjust to remove overcloser. Overcloser is the different issue. Overcloser is like elements are going to be overlap each other, okay, maybe due to the bad quality mesh or maybe due to the interference fit. So let me try. Just click on here, adjustment only, and click on dismiss, and just go with the job, save the file, yeah, copy it. Now we have adjustment. So this is the problem without bolt, and we have frictionless interaction, and we use the adjustment options also. So I am going to remove this copy. Just click on OK and click on submit. Let me monitor. Yeah, here software may able to converge solution for few increments, but still it will not converge the solution for the complete step time. Let's see. Okay, increment reaches up to 10⁻⁵, few more increment, and yeah, solution is aborted. Let me see the result for this. Just click on result and click on here. Okay, so as you can see, this is the scaled result. Actually, I am going to unscale it, or going to keep scale factor as 1. Click on OK. Here we are getting some results, and if you want to see those results, I am going to set all on and click on OK. Just go with the first increment. See, this one is my first increment, and within the first increment itself, this bolt component is going to move in the downward direction along the Z direction. As I told you, this component is not restricted because there is frictionless contact, frictionless interaction between them. This allowed to move in these two directions, positive Z and negative Z direction. But as we use the adjustment options, that's why software will try to make some strain free adjustment or very less strain adjustment, and these much of stresses and results are created. Okay, work closure I already told you in my previous video. If you have any doubt about that, I highly recommend it to go with the previous video. Just go with the last increment. See, but this solution is not converged. This is not a right way to solve the problem. Even the problem is not solved. Okay, just go with here job. Okay, now let me see what will happen if I define the frictional property between these two, not two, three components. Okay, just go with here interaction. I'm not going to change here anything in the interaction definition. Okay, see, I'm keeping same all options as it is. Okay, and I'm going to change the interaction property. Click on edit, and here we have frictionless property. Instead of frictionless, we are going to define here penalty behavior and coefficient of friction 0.2, 0.3, whatever you have, you can define. Okay, so property is defined, then go with the again job. Going to create a new job, just going to copy it. Okay, without bold problem. So instead of frictionless interaction, I have frictional interaction Fi, and I have adjustment options as well, and just click on OK. Now click on submit. Now as I explained, this component having some frictional relationship with respect to these plates, okay, or whole of the plate. Now software may able to converge the solution due to the frictional behavior between these components. Now this bolt is not allowed to freely move in the space along Z direction because of the frictional property. And just go with the monitor and let's see. Okay, first step is not converged for the 0.1 time step. It may possible. Let's see the other increments. Okay, solution is completed. There is nothing like convergence error, and just click on see. Only initially it having a little convergence error, but after that it solve problem without any convergence issue. Just go with the dismiss. Sometime it happen due to the frictional property. It may have larger residue, and to reduce the residue on the particular increment, it reduce the increment size actually. Just go for results, and now click on displacement, and now you can see we have the proper results. And just go with some standard view, and you can see the results. So this is my primary step and this is my last step. Okay, I applied load along the x direction, that was actually transfer load, but here this plate is going to be bent. If you see the deform and undeformed shape likewise, and just go for the last increment. See, I applied only the axial load, but this plate is going to be bent also. just pause the video and think about that, why it is going to be bend also. Okay, when I apply some displacement here, basically I apply some force here, okay, and from this point, this end, it is constrained. So what will happen? On this particular position, some couple will be created. This particular plate end restrict this displacement along this direction, and here at this end the force is toward positive x direction, and here reaction force is along negative x direction. So this particular force, or we can say combination of force, create a couple, and due to that couple this component is going to be bent. So that's not a big deal for us. The main thing, the solution is converged fully, and this is due to the frictional property only. Because we have frictional property, then only solution is converged. Or in other word, we can say, if there is no component which is under constraint, all components are perfectly constrained, perfectly interaction property are defined, then most of the time this problem we may eliminate. But the main task is you have to find out which component is not perfectly constrained, which component is allowed to move freely in the space, and then you have to apply some constraint, interaction, or maybe the another type of constraint. Let me show you one more thing. What will happen if I go for increasing load further? Like here I applied the displacement only 0.2, I am going to apply displacement 2 mm. Just click on OK and dismiss, and just go for job, and again click on submit. Yeah, here this is, I am going to override this. Just click on monitor and let's see. Okay, solution is converged again, and just go with results and let's see those. Click on displacement result, click on some standard view, and you can see the more axial stress as well as bending stress. The reason of bending stress I already explained. So this is not only the way, we have some more way to solve the problem. Actually, this type of component not exist. Even if we have rivet, we have some head, okay, and due to that head, the free motion of this particular component may be restricted, okay. But I am just telling you, if we have such possibilities for any of the component, then what adjustment you can do. Say if we have frictionless property, like click on edit, yeah, throughout we have frictionless property, but few of the component are look like to move in the free space. So just go for define the property. Yeah. So as I told you, this is the not a problem of the overcloser. So this options is not that much useful, but again, if you have any initial interference between the nodes, then you can utilize this options, okay. The third options, same as the second options. Here by default software will choose the tolerance value, and here we will specify the manual tolerance value to adjust or to remove the overcloser, okay. In this options we allow to remove overcloser only from the particular set of element and nodes. So I don't have any set right now, but you can choose, like I want to remove overcloser from only this region. Apart from this region, I don't want to remove overcloser from anywhere else. I want to treat those other regions as interference fit or anything else, okay. So you can choose particular set also. And this last options is very important. See, when I go for no adjustment, there is no sub options. When I go for adjustment options, we have some sub options like tie adjusted surface. If you are facing problem with respect to few component which allow to move in the free space, but actually you don't want to allow them to move in the free space. Just click on here, tie adjusted surface, or you can use these options and you have to select the particular set. But here I have only one region where we have such issue, so just go with here the tie options, click on OK. Even if we have frictionless property, likewise we have frictionless property, the solution will be converged. Why? Because from wherever software is going to be adjust the nodes, and of course here we have, if I check on the elements, here we have some initial overclosure issue. Okay, likewise here we have some initial overclosure issue. Software will automatically going to be tie those particular features. I am repeating again, this options is not recommended, but in rare case you can utilize this options also. So I am going to copy it and adjustment options with tie, and just click on. Okay, one more thing, I have here frictionless property. So frictionless property, interactions, and now click on submit. And let me monitor the solution. Okay, solution is converged very easily, and just go with dismiss and click on results and click on displacement. Okay, so as I mentioned you that this particular bolt component is now fixed with respect to the plates, that's why solution is converged very easily. Okay, here agenda is not to solve this problem. Actually this problem is very easily can be solved if we have bolt head, and in real case we have bolt head. But I am telling you, if you have such any particular component that is not constrained properly, you can utilize those options for that component in the assembly. Like here in the second component, okay, here we have basically two model, with bolt and without bolt. I am going to switch to the with bolt model, and here we have bolt model. So this component is already matched. I am going to click on property. Yeah, frictionless property I have, and hard contact behavior I have for the normal contact, and I defined here three contact. One is between the plate, one is between bolt and hole, actually plate, hole and bolt, and the third contact is between face of the bolt and face of the plate. Oh sorry, this one, you can see here the bolt face, inner surface and top surface of the plate, and here also inner surface of the bolt and this top surface of the plate is going to be interact, and I am not even going to use any adjustment options here. Okay, yeah, for this particular case bolt to hole, here may we have some overclosure issue. If you want, you can go for strain free adjustment, or we can say adjust to remove overclosure. That's all. If you don't want, you can just click on no adjustment and OK. See, even we defined here frictionless property, okay, and try to sort out the problem, solve the problem. Just go for here with bolt WB and the frictionless interaction we have, and there is no adjustment. I not used any adjustment options. Okay, no adjustment options. Click on continue, click on paralyzation options and define number of pores, click on OK and try to submit. As I mentioned you, if you have bolt head, there is no issue to solve the problem. In this video only I want to show you how under constraint part or component can create a problem to converge the solution. Okay, because that particular component can move in space anywhere. Okay, we don't have gravity, we don't have inertia. So solver unable to define its position according to its momentum. It will simply tend to move infinitely. That's why solution diverges. And just click on monitor, and here we can see with the frictionless property, but with the bolt heads we can able to solve the problem very easily. Yeah, problem is solved. Just click on results and click on contour options, and this problem is solved out. So this is all about the under constraint problem. Hopefully in next video I will talk about the over constraint issue. Many times if we choose the contact surfaces in wrong way, it shows us over constraint problem. Maybe few of node choose multiple time as a slave, that's why software shows the error message. So this type of error message we will see in the over constraint issue. So thank you for listening. If you have any question or query, you can ask me, and I highly welcome you to join my Facebook and Telegram group. Link is available in the video description. So thank you again.